stop to think about all the invisible tech that just works? I mean, think about it. You're in a skyscraper, the air is perfectly cool, the elevator ride is totally smooth. You turn on a tap at home, and clean water just comes out. These things don't happen by magic. They're powered by an unseen engine, a piece of technology you've probably never even heard of, but one that literally makes our modern world run. Today, we're going to pull back the curtain on that engine, the variable frequency drive. Just imagine that for a second. No gentle acceleration, no cruising down the highway, just two options, sitting still in park or flooring it, full on, tires screaming. It would be absolute chaos, right? A total recipe for disaster. Well, for a very long time, that's exactly how the most powerful and important machines in our world operated. Yeah, this wasn't just some weird thought experiment. This was the reality for the huge electric motors that power everything from our factories to our water supplies. They were either completely off or they were on at 100% capacity. This meant jerky, incredibly inefficient operation, massive surges of electricity that stressed the power grid, and just a shocking amount of wasted energy. So this all-or-nothing problem, it was a major engineering headache. How do you give a massive, powerful motor the kind of subtle, nuanced control you have with a gas pedal in a car? Well, the answer to that question, it changed everything. And this is it. Meet the hero of our story, the VFD, or Variable Frequency Drive. It's basically a super smart electronic controller that sits between the power grid and the motor. Think of it as a translator, a manager that fine-tunes the power going to the motor. Probably the easiest way to get your head around a VFD is to think of it as a really sophisticated dimmer switch. You know, just like you can smoothly turn a light bulb from a faint glow all the way up to full brightness, a VFD can smoothly adjust a motor speed from a slow, gentle crawl all the way up to full power and literally any speed in between. Okay, so we've got a dimmer switch for a motor. What does that actually mean in the real world? Why is that such a big deal? Well, this isn't just some minor little improvement. It is a complete game changer. Let's dig into the benefits, because they are revolutionary. Honestly, the impact here is just staggering. First off, you get huge energy savings because the motor isn't just blasting away at full power when it doesn't need to be. You get incredibly precise control, which makes everything from factory assembly lines to building HVAC systems way more effective. And, this is a big one, because you get rid of those jarring, violent starts and stops, the equipment itself lasts so much longer. It's a win-win-win. And once you know what they are, you start to realize they are everywhere. They are the silent workhorses of our entire infrastructure. The fans keeping skyscrapers comfortable, the pumps that bring us clean water, the elevators we ride, the conveyor belts in factories. They are all running smarter, quieter, and way more efficiently, all thanks to VFDs. So how does this dimmer switch actually pull off its magic trick? It's a really clever three-step process of basically taking electricity apart and putting it back together again. But before we get into the steps, let's do a super quick refresh on the two kinds of power we're dealing with. Okay, so the power that comes out of your wall socket is AC, or alternating current. A great way to picture it is like the tide. The energy flows in, then out, back and forth. The power you get from a battery, on the other hand, is DC, or direct current. That's more like a river, flowing steadily in just one direction. Now, for a VFD to work its magic on AC power, it first has to turn it into DC. And here's how it does that, in 3 steps. First, the VFD takes that wavy AC power from the wall and shoots it through something called a rectifier. You can think of this like a one-way gate for electricity. It converts the AC into a kind of rough, bumpy DC. Next, that bumpy DC flows into what's called the DC bus. This part acts like a reservoir, smoothing out all the bumps and creating a clean, steady stream of DC power. And now, we get to the final, most important step, the inverter. This is where the real magic happens. The inverter uses these incredibly fast electronic switches. We're talking thousands of times per second. By flicking these switches on and off with perfect timing, it can chop up that smooth DC power and rebuild it into a brand new synthetic AC wave. And here is the key. It can build that wave at any frequency it wants. By changing the frequency, it directly changes the speed of the motor. It's almost like a DJ creating a custom beat, but for electricity. But, this incredible power and control doesn't come for free. This process of rapidly switching the electricity on and off, as effective as it is, creates a side effect. So, all of that high-speed chopping and rebuilding of the electrical wave, it has a consequence.
It creates electrical noise, what engineers call harmonic distortion, and it can actually send that noise back into the power grid.
And we're not talking about a little bit of static here. The total harmonic distortion, or THD, from a standard basic VFD can be over 60%. That is a significant amount of electrical pollution. So why does this matter? Well, this noise can travel through the building's wiring and cause all sorts of problems for other sensitive electronic equipment. Everything from computers in an office to critical medical devices in a hospital. It's basically like having a really loud, disruptive neighbor on your power line. So, this electrical noise, it sounds like a pretty big problem, right? Maybe even a deal breaker? Absolutely not. Because when you weigh this manageable side effect against the unbelievable benefits, the choice is pretty clear. This thing is nothing short of an efficiency revolution. You see, while harmonics are a real issue, they are a very, very solvable one. Engineers have all sorts of tools, like special filters and reactors, that are designed specifically to clean up this noise. And when you think about it, the incredible gains in efficiency and control that VFDs give us far, far outweigh this little cleanup job. The benefits are just too good to ignore. And what a massive impact it is. By letting us match a motor's speed perfectly to the job it needs to do, VFDs drastically lower our energy consumption, they give us far greater, more precise control over our systems, and they make our very expensive equipment last so much longer. When you just step back and look at the whole picture, it's pretty clear that VFDs are one of the most important technologies of the last half-century. They really are the unsung heroes, the invisible engines of efficiency, working silently behind the scenes to make our world smarter, smoother, and more sustainable. It really makes you wonder, doesn't it? What other hidden engines are out there, silently and reliably powering our modern world right under our noses? Something to think about.